Alrighty, guys. Hope you guys are well. This is kind of a continuation of our lectures over the endocrine system. So I just want to finish up. This is a really short lecture over hormonal mechanisms of action. If you remember, before the break, we went over the hypothalamus pituitary axis and how it works and how that stuff works. And remember, I left one part blank. If it's water soluble or lipid soluble, and that was by design because I was actually planning on giving this lecture our first day back, actually, over this. So, and of course, everything's been thrown in the flux. So, let's go and take a look at this real quick and kind of dig into hormone mechanisms of action. So, there are two major categories of hormones. So, we broadly classify them into two categories based on either if they're water soluble or lipid soluble. So, this is back to ninth grade biology, guys. Remember, if it's soluble in water, it means if we drop it in water, it will dissolve and basically disappear, or we can't see it. Okay. If it's not water soluble, there's probably going to be lipid soluble more than likely. So it means it'll dissolve in fat. Okay. And that's really important because water soluble items, such as hormones, such as, let's say, insulin or like thyroid stimulating hormone, for example, cannot cross the cell membrane. And it will not cross the cell membrane at all. Okay. But lipid soluble things such as, for example, estrogen, testosterone, also thyroid hormone's a good one to think about as well. Those will cross the cell membrane. And that's major implications for how these hormones behave, how long they behave for, and where in the body they can go. Okay. So this also determines whether it can directly enter a cell to stimulate its effect, or it can't enter the cell and must stimulate some sort of second messenger inside the cell via the receptor it stimulates. And I'll show you what that looks like here in a second. Okay. Water-soluble hormones typically are large polypeptides, proteins, okay, or also glycoproteins. What does glyco mean? Glyco means sugar. These are proteins with sugars attached to them, basically. Okay, or they can come from amino acids. They dissolve in the blood and do not require carriers to bring them to their target cells. So what makes them unique is because water-soluble hormones are going to be able to dissolve directly into the bloodstream and then travel in the blood to all different types of target cells, okay, directly themselves. They don't need to be carried to their target, okay, because they can dissolve in the blood. However, water-soluble hormones will never not cross the cell membrane. Why? The cell membrane is made of what? Made of phospholipids, phospholipid bilayer. You learned that in ninth grade biology, guys. Okay, lipid-soluble hormones are smaller, and they're derived from cholesterol. That's what makes them a little different. So our water-soluble hormones all come from proteins and glycoproteins and amino acids, while our lipid-soluble hormones will come from cholesterol and cholesterol only. Okay. However, they require a carrier protein because they can't dissolve in the blood. These are when they're fat soluble, you're not going to be water soluble. When you're water soluble, you're not going to be fat soluble. Now, thyroid hormone's a little bit of an oddball because it's slightly soluble in both, but we tend to consider that one to be lipid soluble by definition. Okay, but all the lipid soluble ones are going to require some sort of protein carrier. We're not going to go into what the carriers are. Just be aware that because the lipid soluble ones cannot dissolve in water, they're going to need a carrier protein that's going to carry it to the target for it. Okay, so examples of hormone types. So all of the hormones for the hypothalamus. So things like growth hormone releasing hormone, dopamine, CRH, TRH, and GnRH, all those, and also all the hormones of the anterior pituitary. Remember flat peg, FSH, LH, ACTH, TSH, prolactin and growth hormone, flat peg. That mnemonic I taught you guys before. Okay, all those hormones. So if you're from the anterior pituitary, or if you're from the hypothalamus, or the posterior pituitary as well, you will be water soluble. Okay, so that means you dissolve in the blood, you travel to your target cells through the blood, and you stimulate your receptors on the cell surface, and you stimulate a second messenger that will do the effects for it. So remember, all our water soluble hormones cannot and will not cross the cell membrane. They won't do it. Okay. Also, too, Insulin, glucagon, parathyroid hormone, and calcitonin are also water soluble as well. So the ones that regulate sugar and calcium also are water soluble as well. Okay, now the way you want to handle learning this is note this way: thyroid hormone, sex hormones, and lastly, adrenal cortex hormones are all lipid or fat soluble. So there's 6 of them. There's thyroid hormone, estrogen, testosterone, progesterone, aldosterone, and lastly, cortisol. Those are all going to be lipid soluble. All lipid soluble, guys. Okay, and they will always be lipid soluble. They will not dissolve in water. Okay, they only dissolve in fat. However, they can cross the cell membrane. But that being said, they need a carrier to carry them to their target cells. Okay, our water-soluble hormones. Here's the mechanism of action. So if you see here, in the picture I provided for you guys, epinephrine will bind to its receptor. This is a receptor here it's binding to, and it stimulates what's called a G protein. And the G protein will then stimulate a second messenger. This is an enzyme here called adenylyl cyclase. And adenylyl cyclase will take ATP and make something called cyclic AMP or CAMP. And CAMP serves as the second messenger. Okay, so water-soluble hormones have receptors in the cell surface. So remember, water-soluble hormones cannot cross the cell membrane. So their receptors have to be on the cell surface. They have to be there. They will always be there. Because why? They're water-soluble. Meaning, remember, if you think about the chemistry, if you took chemistry already, water solubility means you've got some sort of negative or positive charge on it. So if it's got a negative or positive charge, it's not going to cross the cell membrane. Can't do it. It won't do it. It'll be blocked. So it gets kicked out. Because remember, no charge things hate things with charge on it. So they repel each other. They push away from each other. So the water soluble hormones have the receptors on the cell surface, and they stimulate a second messenger. The second messenger you want to know is CAMP. That's the big one you want to know. You want to know CAMP. Okay? So the hormone, the first messenger, will not enter the cell. It binds to the receptor on the plasma membrane or the cell membrane. So the hormone binds to the receptor on the plasma membrane. Okay? This hormone receptor complex activates what's called a G protein. And this G protein will generate the production of a second messenger. There's 2 big ones you probably want to know. One is CAMP, cyclic AMP, and the other one is IP3. Don't ask me what that stands for. I know what it stands for, but I'm not going to go into that with you guys, okay? It's cyclic AMP and IP3. Those are the big ones. Okay, cyclic AMP will stimulate protein kinases and other things. Okay, IP3 typically stimulates the production and release of calcium from a place inside the cell. Okay. The second messenger will then signal other intracellular chemicals to produce some response in target cells. So basically, again, the water-soluble hormones will not enter the cell. They bind to a receptor, stimulate a second messenger, and then that second messenger will go out and carry out the message throughout the cell. Okay? And the big ones you want to know are CAMP and IP3. Okay? Now, the advantage of water-soluble hormones is this is a fast process. We're talking minutes to hours at most. So, for example, from the time you take let's say I know I'm home and I'm being lazy, I've been eating a lot of pizza. From the time you take your first bite of pizza, within 10 minutes, insulin's already working in your body. Insulin's already been stimulated to be released by the beta cells in the pancreas. They've been released. Okay, and within 15 minutes, insulin's already stimulating its effects. It's pretty awesome. Okay, pretty fast. So water-soluble hormones work over much faster, much quicker time periods, minutes to hours. Okay, they're much shorter acting, but also they go away much faster too. Within 2 to 3 hours, sometimes 4, maybe even longer, they're gone. This is not going to be around for a very, very long time. And it makes sense. We don't want insulin constantly doing its effects, because if that happens, our blood sugar would be way too low and we probably would die. Our brain would probably shut off because of that. Okay, now fat-soluble hormones. You see here's your image here. This is steroid hormone. So remember, these are all steroid hormones. So that's so things like estrogen, progesterone, testosterone, cortisol, aldosterone, one of those. So you see, this is fat soluble. This is lipid soluble. What makes this cool and unique is the fact that it can cross the cell membrane. Okay, so you're going to find the receptors for fat-soluble hormones in the cytoplasm of the cell. They'll be hanging out in there. Okay, so there's no receptors for steroid hormones on the cell surface. They're going to be inside the cytoplasm waiting. Okay, so fat-soluble hormones bind to receptors within the target cell, and they influence cell activity by acting on specific genes. So what this is what's called a transcription factor. We mentioned this back in September when we went over cell biology. So transcription factors basically will increase or decrease transcription. Okay, usually increase. Okay, so what's going to happen is we're going to make some new proteins. So steroid hormones cross the cell membrane, bind to receptors, and the hormone receptor complex get together, and then we bind them to the DNA, and we make some new proteins, basically. So it diffuses freely into the cell. Okay, well, cytoplasmic nucleoprotein surface receptor. So usually there's some sort of protein receptor, usually in the cytoplasm, sometimes in the nucleus, but it's going to be the answer on the test is going to be where's receptor for steroid hormones. It's going to be a cytoplasm every time. Okay, that's the answer. Cytoplasm. Okay, they combine together, they enter the nucleus together, and then we make new proteins. Okay. So this is called a hormone receptor complex. Okay, and it binds to what's called a steroid response element, SRE, a little beyond our scope for this class. Just know that steroid hormone crosses the cell membrane, binds the steroid hormone receptor, they form a complex, they bind the DNA, and they make new proteins to the end. Okay, and it turns target genes on or off. Usually it's on, but sometimes it can be turned off. This is a much longer process. We're talking days to sometimes weeks, guys. So, for example, when you guys are going through puberty, either steroid or estrogen was being released by your gonadal cells, either Leydig cells in boys, or the ovaries in females. We released a lot of that hormone, and that diffused throughout the entire body. So that went to guys. You started getting hair underneath your armpits. You started getting a deeper voice. You started getting a bit taller. You started noticing changes. You started noticing changes to your genitalia. You started getting pubic hair. You started getting facial hair. You started having other things happen to you as well. So you start getting hair on over your lip. So that stuff didn't happen overnight. It happened over the course of weeks, months, even. So when fat soluble hormones work, they work over a much longer period of time, at least days, sometimes with the orders of weeks, and even longer sometimes. Okay. So what are your Mr. Take-home message here, guys? So what do you need to know? So what we need to know. So we need to know there's a big difference in how water-soluble hormones and fat-soluble hormones behave. Water-soluble hormones are going to bind to receptors on the cell surface, okay, and stimulate a second messenger. It can be there's a lot of different ones. I mean, I just told you two. There's actually a lot more than that. But the big two you probably want to be aware of are cyclic AMP or CAMP and IP3. Those are the two you probably want to know. Now, fat-soluble hormones or lipid-soluble hormones are going to be different. They come from cholesterol, sometimes also called steroid hormones. They cross the cell membrane. They enter the cell, bind to a receptor in the cytoplasm, and then upregulate transcription and making of new proteins. Water-soluble hormones are going to work in minutes to hours, while fat lipid-soluble hormones are going to work over the course of days to even weeks, if not even longer. Okay, so hope that helped you. I hope that helped shed some light on the difference in mechanisms of actions, because it's a really important thing to know for the quiz coming up for you guys. Okay, if you need anything, of course you know where to reach me. Hope you guys have a great day, and I will talk to you guys soon.